In this online lecture, we're going to talk about how you can determine the rate law expression from experimental data. Okay, so let's say we have two reactants. We have this equation where we have reactant A reacting with reactant B, and these two are reacting to give us C. This equation is balanced. Okay, we have two there, we also have one, then three there. So the rate law expression for this equation can be given as follows. So we have rate equals K, which is lowercase k. K is the rate constant. Then you have the concentration of A. We know the units for concentration, moles per liter. Then we have also reactant B, concentration of B. Then A is going to be raised to the power X. Then B is going to be raised to the power Y. X and Y are the reaction orders. They are called reaction orders. K is the rate constant. Then the overall order of this reaction can be calculated by adding X plus Y. So this is how you calculate the overall order of this particular reaction. So now, what we need to understand here is that if you are determining the rate law expression for a chemical reaction, you don't consider the concentration of the products. You have to consider the concentration of the reactants only. So you can see in this expression, I've only included the concentration of A and B, which are the reactants for this given equation. Another important thing that you also need to consider is that the reaction orders X and Y, these are not equal to the stoichiometric coefficients in the balanced equation. So you can see in the equation we have 2 and 1 as coefficients for the two reactants. Then for the rate expression we have X and Y. So X and Y are not equal to the coefficients. Now, if X and Y are not equal to the stoichiometric coefficients, where can you get them? The reaction orders are determined from the experimental data. We'll look at how you can determine the reaction orders. We need to understand what this particular expression means. So if you have an expression like this one, what it means is that the rate of the reaction is first order with respect to A, second order with respect to B, third order with respect to C, zero order with respect to D. The overall order for this particular expression can be found by adding the exponents. So the overall order for this reaction is equal to 1 plus 2 plus 3 plus 0. Okay, so that's 0. So the overall order for this particular reaction will be 6. So we can say this reaction is 6 order overall. So we have been given this question and we are required to determine the rate law expression using the experimental data given in the table. Okay, so for us to do that, we are going to start with a general form of the rate law expression. So we expect our rate law to be equal to, we have two reactants in the equation. You can see we have reactant A and reactant B. So we should have the rate constant K. Then we need to have the concentration of A. Okay, then this is going to be raised to the power X because we don't know the order of reactant A. We raise this to the power X. Then we are supposed to have reactant B. Then we raise this to the power Y. So we have two reactants A and B, and we expect these to be in the expression. After writing the general form of the rate expression, we need to determine the value of X and Y. We have the general form of the expression. We need to find now the value of X and Y. So for us to do that, we need to compare the experiments where the concentrations of A changed and the concentrations of B remained constant. Experiment number 2 and number 3 here. You can see that the concentrations of B remained constant while the concentrations of A were changing. So for us to calculate the value of Y, for us to calculate the value of X, we're going to use experiment number 2 and experiment number 3 because the concentrations of B remained constant while the concentrations of A changed. So we'll use experiment number 2 and experiment number 3 in order for us to calculate the value of X. All right, so let's do that. To solve for X, this is the formula that we're going to use. So we'll use the concentration of A from experiment number 2 over the concentration of A from experiment number 3. Then X as the exponent equals, then we're also going to use R2 over R3. A2 is 0.30 over 0.10. Then we have X there. R2, this is R2. Then R3. So after dividing, we're going to get 3x equals 3. To solve for x, we're going to take the logs of both numbers. So meaning the value of x here is 1. So x equals 1. So to calculate the value of y, we're going to compare the experiments where the concentrations of B changed and the concentrations of A remained constant. If you look at this table, you can see that experiment number 1 and experiment number 3 here, 1 and 3, the concentrations of A for experiment number 1 and experiment number 3 remained constant while the concentrations of B changed. So meaning we're going to use the initial rate for experiment number 1, the concentration of B, and also the concentration of B for experiment number 3. So we're going to use experiment number 1 and experiment number 3 to calculate the value of Y. So for Y, this is the formula that we're going to use. We're going to get the concentration of B from experiment number 1 over the concentration of B from experiment number 3. Then we're going to raise this to the power of Y. Then we're going to get R1 over R3. So this is the formula that we're using. So now we can do the division. So to simplify this, we can introduce logs. Okay, so that means that y will be equal to log 1 over log 0.33. 0.333. So this is going to give us 0. So meaning y equals 0. So now we now have the values of x and the values of y. So we can write the rate law expression. So it's our expression. So rate equals k, then a raised to the power 1. So if this is 1, we don't have to indicate 1. Then b is raised to the power 0. Okay. So we can as well write the rate as follows. So this is the same as k. Anything raised to the power 0 is 1. So we can also write it like this, or if we want, we can write it like that. It's all the same. So that's the answer for the first part. Now the second part was asking us to calculate the overall order of the reaction. So the overall order, we have to just add the exponents. So we know that here there's 1, so it will be 1 plus 0. The overall order will be equal to 1 plus 0, which is equal to 1. So the overall order of this reaction is 1.